Howdy! Welcome to Workshop Wasteland. If this is your first time stopping by, thanks for being here. If you've been here before, welcome back. Hopefully everybody had a fantastic Christmas and a Happy New Year. Can't wait to see what the year has in store for me here in my little workshop, as well as from all of you and your respective YouTube channels. So, Merry Christmas, Happy New Year. Super awesome to have you here. We're going to get started on a little, almost micro engine build series. Only going to be 3, at the absolute most 4 videos long. Try and get everything done in a shorter amount of time. This is probably a fantastic beginner's engine or a first-timer's project. It's called the Scotty. As you can see right there, it uses a little Scotch yoke, so the crankshaft basically just goes in a straight line back and forth horizontally. It's a pretty neat little design. I don't really know where it originates from or who kind of invented it, but this is all of the plans for it right here. So as you can see, it's not too many pieces to make. It's all on one page, which is really awesome. So we're going to go ahead and get started on this thing. By the end of this video, if you're following along, you'll have a flywheel made. You'll have a base, an upright, or they call it the frame, and our air inlet and bearing all created. The best part about this is it's small. It doesn't need big pieces of materials. Really doesn't need any fancy equipment whatsoever as far as tooling. So, like I said, probably a great project for a first-timer. So I guess, what do you say? Let's get to it. Start out back here on the mill. Alright, we'll get started here with the frame, as they call it. This is a piece 2 1/16 by 1 inch, and it's made out of 1/4 inch thick aluminum. Have to drill a couple holes and get this thing laid out, and then when we're done we'll cut this notch out. I scribed everything to lay it out. Again, that's what I like to do. Everything is indicated from this side and basically from this top. So as you can see, these holes are extremely close to the edge. So I pulled this back parallel out, which means this is probably not the most perfect setup in the whole wide world. But at the end of the day, it's not that big of a deal. This isn't an overly critical piece to machine. And it's so small that what little bit of error that may have induced is not going to hurt a thing at all in this setup. So the first thing we need to do, this center hole right here needs to get reamed to 3/8, and it's 17/32 down from the end, so that's 5/31/3. I'm not going to worry about the 3/100ths. There's 5/31, and then unfortunately on these plans they don't really give any center lines anywhere, so you have to get creative with your math. So it's 3/12 down, so 5/16 down this way, and that's right there. This is a spotting drill. So we'll give that a spot face. Now for the next 2 holes, they are 17/32 plus 11/16, so that's 1.2 down right there, 1.2, and they are 94 thousandths. Sorry if you hear my 3D printer in the background. I'm working on a really cool project, so apologize for that. And this one is at 5/31. Now we need to go 11/16 further, which is 1/887. Okay, that's all my holes spot faced. We can now drill them. It's calling for a number 43 drill for those. I think this is clearance for a 256 screw. This is a number 1 drill just because it's real handy right now. Still undersized for 3/8. One size under 3/8 is 23/64. Now we'll hit that with a reamer, and this piece is almost done in this setup. There's that hole reamed. Now we need to cut out that corner, but I'm going to wait until I drill the rest of the holes in that. So I will get those laid out. I'll get this all deburred and set up for the next operation. I'll be right back. Alright, so this is a super easy operation. We need to drill 2 holes in here, 256 threads. They are spaced 3/16 apart. So I already had my reference point for this back jaw, so now center of this being a 1/4 inch is 125 off the back jaw, and the first hole we need to come down 218 from this edge, which is the top edge. So we'll give this a quick dimple. And then our next mark needs to be 406 down. So that's the 2 dimples. Now we can drill this tap drill for a 256 as a number 50. Alright, that's those 2 holes. Now I have to do literally the same thing on the bottom. You can see my scribe lines for those 2 holes. I'll do those off camera. And I also drilled this hole most of the way through off camera. That was drilled with a number 1/16th drill bit. Then I'm going to cut this piece out, and that'll be pretty much it for this piece. We do have to drill a long hole all the way through here, which I'll bring you back to do whenever we do actually accomplish that. Alright, so off camera we got these holes tapped for a number 256 screw. As you can see, we still have to cut this piece out, and then we need to drill that long hole down through here. But before we drill this long hole, we need to put a bearing in here, or a bushing I guess you would call it. So we're going to machine that now. This is some sort of bronze, I don't know what it is, phosphor bronze or something. It's an offcut from another project, but the pieces on here are about right. So let's go over to the lathe and we'll get this thing made real quick. Alright, so the plans call for 3/8 here on the end and then 7/16 up here. I don't think this 7/16 is super critical, but whenever it's not critical, I like to try and practice hitting dimensions dead on. Only because, you know, good practice makes good habits. So it's pretty oversized right now. 7/16 of course is 437, so let's see if we can nail 437 out of that. It may be a bit of an interrupted cut to start because I took this out of the jaw chuck, or the chuck jaws at this point, obviously. We're about 3/10 under, so that's perfect. Like I said, I don't think that was a super critical dimension anyways. Now we need to cut a 3/8 fit that's going to fit inside of this 3/8 hole that we bored. So it may not be dead on 3/8, especially if you, at home, if you just drilled it and didn't ream it like I did. And that needs to go for a depth of 21/64. So let's first get this round and see where we're at. So there's our 21/64. We'll go a touch farther on the next cut so we can clean off the end of this. This should not fit yet. It does not. Probably force that on, and it doesn't leave anything for one cut to grab. Because we need 2 thou. There we go. That's the fit we were looking for. It slides on, but it just slides on. Very little movement, so that's perfect. Now we can check our length, which again is 3/28. That's 330. I'm sure that is perfectly fine. And now this gets a 3/16 hole bored through it. This is going to be a number 14 drill, then I'm going to switch over to the 3/16 reamer. That done. Now I'm going to take a very, very light skim cut off the face of this to get rid of that burr. And the overall length of this thing is 11/16. So I'm going to get this parted off camera and I'll get you set up in the mill for the next little operation. Alright, well, here's what we're left with. This is the bushing or bearing or whatever you want to call it. It is 3/8 here, 7/16 here, and the overall length was 11/16. Polished up a shaft that spins real nice on here. This is going to be our crankshaft, I guess you would call it. But as you can see, that works out really well. So let's take this over to the mill and finish it off. Alright, got this clamped in the vise. I edge found both sides here and came to the center. I also edge found my vise jaw and moved back half the thickness of my edge finder. So now we need to drill a 1/16 hole. We need to drill 11/64 1 inch off the back. It doesn't say what size to drill the hole ultimately, but I think we're going to drill it a 1/16 of an inch. So 11/64 off the back, 171, and that's going to come down. We got a super tiny center drill in there. And now we can drill a 1/16 hole in there. Alright, so we need to drill until we intersect the other hole. Should be able to feel whenever it breaks through. That broke through. Now we need to spot that with a 3/16 end mill. Okay, like I said, we need to spot this with a 3/16 end mill because we are going to solder a small piece of pipe in here, small piece of brass tubing. So I'm just going to kind of do this by eye. So for reference, that's about 63 thousandths deep, which should be just great. Now I'm going to solder that tube in there and that piece will be complete. Alright, here's our little piece. We got a piece of 3/16 brass tubing soldered in there. Just typical plumber's solder. It was actually electrical solder. We're going to do one final operation to our frame, and then I will show you what we're doing with this piece. So stay tuned. Over here on the frame, we're going to cut out this notch. Like I said, I scribed this on before. I'm just going to cut to the scribe lines. It's not super critical. Dimensionally, it's really just an aesthetic kind of cut. It doesn't give a diameter or a radius for the inside of that in the corner, but I'm going to keep this 3/16 end mill in and use that, and it'll be just fine. Again, this is a purely aesthetic cut. We're not doing anything precision with this, just making it look nice. So that's going to be my 0/0. This is not a great setup, so definitely need to take light cuts on this. Whenever you set up, you should really ultimately have this supported. I don't feel like breaking out a little machinist jack for this little cut. Alright, there's that cut. Just got to deburr it and that is done. So that's the cut that we just made. As you can see on the plans, we end up with what we're supposed to end up with. The next thing I'm going to do is clean this all up, get it looking real nice and shiny, and then I'm going to Loctite this piece into here with the tube pointing out nice and straight. And the final thing that we need to do for these two pieces is drill that 1/16 inch hole all the way through here into our little bearing. I'm going to Loctite this in and we'll let this cure overnight. So in the next video, probably the first thing we do is drill that hole. Alright, so the flywheel is 1 3/8 diameter and it's 5/16 wide. So this is a piece 1.5 stock. It's the closest thing that I had that isn't a big piece and have to cut a chunk off of. So let's go ahead and give this a try. Start with facing off like pretty much we always do. I want to go a little bit more than a 1/2 inch on that because I need to be able to get my parting blade in there then. Dang, sure is throwing some chips today. Must have a pretty nice sharpening on this tangential tool holder. Basically 1.4. Again, this is not a ridiculously precise cut, so alright, not a terrible surface finish. This is 12L14. Alright, we're at 7.3, so 1.373. Close enough. Now we need to drill and bore a hole. So that was number 14 drill, and now this is the 3/16 reamer that we used before. Slowed the lathe way down for this cut. Now we'll do a little bit of a decorative cut here on the end, just to make it look nice. Again, this is a purely cosmetic cut. This isn't even in the plans. I'm just doing it because I want to. Now we can run the lathe backwards and trim up this face. Yeah, that's not too bad. Alright, now we got to part it off. Alright, to get this parted off, it's a pretty easy process. I'm going to put an indicator up against the back side, and my parting blade is 93 thousandths. I had it touching this face right here, so I come in 93 thousandths, re-zero my indicator, and then this is 5/16 wide, so we need to come in 5/16 now, which is 312. 1, 2, 3, and we're going to go to 320 just to make sure we have a little bit to clean up on the other end then. Set up my stop there. I'm going to hit this real quick with a 45 on this outer edge. Hopefully I can get close enough. Oof, barely. Just give that a nice little chamfer. Because chamfers separate us from the animals, right? Alright, everything's locked down. We should be ready to rock and roll here. A little bit of oil. I'm going to move you back so my camera doesn't get covered in oil. Whew. Barely had enough stick out on my parting blade, but we got it. All right. There we go. I'm going to, off camera, probably try and hit that with a file, and that will be our flywheel. All right, well, there we have it. Part 1 of this little Scotty engine build series. So far, so good. Looks pretty easy from here forward. Like I said, this is kind of geared towards a beginner or kind of a novice machinist like myself. I'm by no means a seasoned expert, just a guy in a garage having a great time. Hopefully I can inspire you to do something similar in your shop at home and maybe even build one of these engines. I showed you just about enough without even having the plans to be able to get this done. So, you know, with any luck, I can inspire someone to get it going. So this is where we're at right now. As I showed you in the beginning of the video, I now have the bearing Loctited in there. The first thing we'll do when we come back the next time is drill that long hole down through there for the air passage. Got the flywheel all done with a little bit of a decorative recess in there. I may drill a bolt circle around there and make some holes in it. I haven't decided yet. I have the cylinder ready to go for the next video. As you can see, it's pretty darn small. So that's the best part about this engine, is you don't need all kinds of huge pieces of material that are expensive to machine this. If you have a scrap bin, probably everything you need is already in there. So like I said, hopefully I can inspire somebody to do something similar in their workshop at home. And if not, hopefully you enjoyed the entertainment. Hopefully you learned something. Please don't forget to like and comment, and I'd love it if you subscribed. We'll see you next week in part 2 of the Scotty engine build series.